This example is very important. We will use this example to illustrate a key idea, which is partitioning of n objects. Let's use this to illustrate. The first two parts are easy. The third and fourth pay close attention. How many ways can 6 men be divided into 6 men divided into 3 groups? First group is 3 men, 2 men, 1 man respectively. So we look at it pictorially. It's like that. Number of ways I can pick the first group, which is a 3-man group here below. 3-man group here, right? Is you choose the 3 first. Then after that you choose the 2. After that you choose the 1. So, and when we choose, again, within this M2, M3, and M5, for just an illustration, the order needed matter. So how many ways can I pick? 3 out of 6. Then remaining 2 out of 3, the remaining 1 out of 1. So simple and straight, it is what it is. It's done. Alright, you multiply because you do it successively. Now, what if you want to break the men up into 3 groups? You have a first double, second double, and third double here. So we do exactly the same thing. We choose the 2 from a group. Choose 2, it may be 2 and 3. Alright. Then the second group, it may be 4 and 6. Then finally the 1 and the 5. So you do exactly the same. You take 6, choose 2 instead of choose 3 earlier. You choose the 2 first. Successively 4 choose 2, then 2 choose 2. Done. So what's so good? And when I calculate this 4, 6 choose 2, I could have picked M4, M6 as the first pair, M2, M3 as the second pair, and M1, M5 as the third pair. Correct? And these 2 cases are considered different cases in this, because when I say 6 choose 2, I could have chosen M2, M4, M6 here. So the order matters here because there is a first pair, there's a second pair, and there's a third pair. The reason why I highlight this is because in part 3 here, the question is asking how many ways can I break the men up into 3 groups where you have 2 in each group. If you have your notes in front of you, you may want to take a look at the phrasing as together in a line. Part 2 and part 3 look similar, but they're slightly different. So what you may do, you may think, I choose the first pair, I take 6 choose 2. Second pair, I take 4 choose 2. The third pair, I take another 2 choose 2. Now, if you had done that, you would realize that these 3 groups, there isn't a first pair, second pair, third pair here, because the question only said that I need to have 2 men in each group. There is no first pair, second pair, third pair. Alright, the groups are not ordered whatsoever. So, in another situation, as I wrote just now, in another situation, if you have picked M1, M2, M3 here, but instead the 4 choose 2 here, if I pick M1 and M5 here, and then I pick M4 and M6 here, these 2 are actually the same grouping. It's the same grouping because the 3 pairs, you don't have a first double, second double, third double. Similarly for this one, correct? If you look very, very closely, it's M4, 6, M4, 6, M4, 6 here. Yes? And then the 2 and 3 are partnered, 1 and 5 are partnered. And so on and so on. So there are actually how many ways you look at it? If this is the first pair, this is the second pair, third pair, it can be 1, 2, 3, 3, 2, 1, ABC. If I use ABC to label it like that, if I call this group A, group B, group C, there are actually how many? 6 different ways of arranging ABC. And for every 6 cases that you have counted, technically it's only 1 case. I say one more time, for every 6 cases you counted. Why 6? Because it can be ABC, BCA, it's actually 3 factorial ways. For every 6 cases, it's only 1 case. So the final answer must be, first, I treat them as an ordered pair. That means there is an ABC. 6 choose 2, 4 choose 2, 2 choose 2. This is your answer to part 2. But I have 6 counted. You know what I mean? I'm 6. I've counted the number of cases by 6 times more. So I divide by 3 factorial. I divide by 6 here. I write 3 factorial because it is very clear it is ordered of ABC. So I divide by 6. I get 15. What if now, slightly different, I have 4 men, 1 man, 1 man. So immediately, same one. I choose 4, correct? 6 choose 4. I take 2 choose 1, and I take 1 choose 1. So therefore, but the problem here is when you take 2 choose 1 times 1 choose 1, correct? You are saying that it's a first, these two, the order matters. But in actual fact, they don't matter. When in actual fact, they don't matter. So what you need to do, you can see here, these two, we have counted these two cases as separate when in fact they are the same. Because the moment you take 2 choose 1, that means you have 2 ways to pick this one. But in actual fact, there is only 1 way to pick that. So you must divide by this 2 factorial. Why? Because you have counted them as a ordered pair. Correct? In the previous part 3 example, you have 6 times counted more 6 times. But in this case, you have double counted only. So you divide by 2. You don't divide by 3 factorial because the 4 men is 4 men. It's distinct. You only double counted in terms of this rotation of these two. Alright? So therefore, you divide by 2 factorial. That's that.